In our previous class, we have already discussed inheritance, which can be used for code reuse and for polymorphism. Today, let us see interfaces. The main objectives of using interfaces in software design are to achieve the loose coupling and create flexible and modular designs. We have already discussed polymorphism while discussing inheritance. To fully exploit the power of polymorphism, we need interfaces. Interface polymorphism allows for more flexible, decoupled, and reusable designs. In Java language, interface is an abstract type. Interface is 100% abstract class. Interfaces are used to declare behavior or contract that classes must implement. Means, interface specify a set of methods that implementing classes must provide. Let us see how to define an interface. With this syntax, interfaces are defined, interface keyword and interface name. Within the interfaces, we can declare constant declarations and abstract methods and static methods. Interfaces can extend other interfaces also. We can specify visibility for the interfaces. These two are optional, but this interface keyword and interface name is mandated. Let's take simple example. If I want to define interface bounceable, then we can declare like this: interface name bounceable here, and one constant declaration phi 3.1415 and one abstract method set bounds. All interface methods are public and abstract, and they can never be final methods. Think all the interface methods as prototypes only. No implementations are allowed. Similarly, all interface fields are public, static, and final by default. So, in this bounceable interface, this constant and method declarations will be modified by compiler like this. Since all fields are static and final by default, so this will be added, and all methods will be abstract and public, so this will be added by the compiler. Let's take simple example: payment processing system for e-commerce platform. E-commerce platforms like Flipkart, Amazon might support multiple payment methods like credit cards, debit cards, net banking, and UPI. Each payment method would be implemented differently, but they follow common interface, which allows system to process a payments in a uniform way. Let's say you have interface called payment method that defines method for processing payments. Now you can have multiple classes that implement this interface, each handling different payment method. Let us write the program for that. Create Java project, interfaces, delete this module info.java. Let's create new Java class, call it as payment service, and add main method stuff. Let us create the interface payment method. We can create the interface by using interface keyword. Assume it has one abstract method, process payment. Will accept amount, which is of type double. Interfaces will not have method implementation, only prototype will be there. So let us add semicolon here. We have multiple payment methods like net banking, UPI, and credit cards. We need multiple classes to implement all these kind of payment methods. So let us create one class for each payment method. For simplicity, here I am considering only credit card payments and UPI payments. Let us create the credit card payment class. This class need to implement this payment method interface. This credit card payment implementing this interface payment method, so it needs to provide the body for this process payment method. Here I am adding just dummy implementation. Processing credit card payment of. Here logic for the credit card payment will be added. Credit card payment logic goes here. Let us add another class for UPI payments. Let's copy this and here. Let us create one variable payment, which is of type payment method interface. Suppose if one user selects credit card payment, then this reference variable payment will be assigned with the credit card payment object. Now with this reference variable, call this method process payment. Let's say amount 1000. Suppose if you got UPI payment, then payment will be assigned with UPI payment. Let us run this program. We got this output: processing credit card payment of rupees 1000 and processing UPI payment of rupees 2000. Like this we can define interfaces and implement that interface by using different classes. Let us see the advantages of interfaces. Interfaces are mainly used for loose coupling, means separation of contract and implementation. In this example, this payment service class only depends on this interface payment method, not on any specific payment method, means credit card payment or UPI payment or any other type of payments. Since implementation and contract are decoupled, so this payment processing system is highly flexible and extensible. As new payment methods emerge like UPI, they can be integrated into the system without modifying existing code. Here we are creating reference variable of type payment method interface, and we are assigning different kinds of payment objects. Instead of interfaces, if we use the abstract classes or classes for inheritance, then these subclasses will be tightly coupled to the superclass. Changes made in the superclass will affect the all subclasses. Since implementation and contract are decoupled, so payment processing system is highly flexible and extensible. With interfaces, we can achieve the complete abstraction. Abstraction is achieved here by using this payment method interface. This interface defines a general contract which abstracts the payment processing, hiding the implementation details from the user of interface. This means that the payment service class does not need to know how each payment method works internally. It only needs to know that each payment method can process payment. Another main advantage of interface is polymorphism. See here, the payment service does not need to know at compile time which payment method will be used. Instead, it can be determined at runtime. Since here, reference variable payment of type payment method interface, so this payment variable can refer to any object that implements the payment method interface. The e-commerce system does not know until runtime whether it will process the credit card payment or UPI payment or something else. This allowing the same code to handle different payment methods. See here, payment.process payment, which is executing this method which is in the credit card payments. Since here object is of type credit card payment, same code payment.process payment. Now this is executing method which is in UPI payment class, since object is of type UPI payment. Here this code payment.process payment. Whenever this method is called, JVM uses late binding to determine which payment method to invoke based on the actual object type that payment is referring to at that moment. This kind of late binding makes the system extensible. New payment methods can be added with minimal changes to the existing code. We can also achieve multiple inheritance by using interfaces. We will see that later.